So good day and welcome to the ESC TV Connect. Today we're gonna discuss a newly funded consortium. It's called AI for Heart Failure. I'm Folkert Asselbergs. I'm a prof and a consultant cardiologist at Amsterdam University Medical Center. Together with Kazem Rahimi, prof at Oxford University and also cardiologist and part of the consortium, we're going to discuss AI for heart failure. It's an ambitious program. And I will just quickly outline what the different work packages are and the main aim, and then we're going to discuss the challenges of implementation of AI within routine care, discuss trustworthiness and fairness of AI models. So our consortium is really designed to start off with the clinical and patient requirements. Really, so starting from what do they need, what they do expect from AI, how they want to implement it and use it in routine care. Then we have a stakeholder meeting with regulatory agencies, with LCs, so they're ethical and legal experts, to see, okay, what's needed to get to a proper AI algorithm, because as we've seen in current practice, often it starts off with an AI algorithm, we implement it, and then we're going to ask questions, okay, how do we going to implement exactly in the clinical care pathway and involve patients? Well, we really want to circle it back and start off with the patient, the clinical requirements, and then move into the AI, which is one of the prime objectives for Oxford University, and they're going to test it across Europe, so not only in a few countries, but really in diverse populations. And I think it's really cool from this project where we also have partners from Africa and South America, where we can really validate AI algorithms. But today the discussion is predominantly about the best practice for trustworthy AI. It's called Future AI. Go to the website futureai.eu regarding fairness and how to implement it in a trustworthy way. And let's start the conversation. Kazem, thanks for being here. And I think the main topic is maybe not the AI itself, but it's how do we bridge from the expectations, the hype, into real world practice, and how do we bridge that gap? And what do you think are the challenges that we need to conquer?
First of all, great, thanks for the introduction. I mean, I think as you described it, the exciting thing about this is that we bring in really different disciplines together and different stakeholders to trying to just overcome that challenge. What we have seen so far, particularly in the academia, that we have been focusing a lot on the sort of development of the algorithms themselves, and this is also what happens a lot of the time outside academia. But what exciting is just how can we get it actually into practice? And once you start thinking it, you see suddenly that the challenges are different. And we have thought about a number of them in this program, as you know, and I've implemented it. I got the right experts on board. But I'm sure as we move forward, many of those challenges that we anticipated will turn into different directions, and thinking about it and going forward requires probably input from additional experts as we go in this. But fundamentally, I think one of as a sort of a high level, the challenge is the implementation challenge, right? How do you go from an AI, which typically is likely to be an algorithm developed in a particular setting, to just get it into busy clinicians' world and make sure that at the same time it performs the way you thought that it would perform in a more artificial environment of a lab-like environment in practice. And there are different aspects of it that one could think about, but fundamentally it is that level of does it perform in the same level. And we could go into the aspects of a discussion about data access, trustworthiness, to what extent is it interpretable, to what extent is in an environment where AI keeps changing and the data might be changing, how can it adapt and yet still be trustworthy and perform in a way that we would like it to?
Yeah, so you address a key point is the adaptiveness and also the dynamics, right? And it's for regulatory agents quite difficult as well.
Yeah.
So how do we make sure that we're still, it's still valid what we're doing? Do you have is there some kind of technical solution or a way that you think that we should?
I mean, I've got some ideas, but ultimately we would need to work with regulators, we need to work with some experts, including probably societies such as the European Society of Cardiology, to think them through. And I think the AI program that we have gives probably an experimentation bed to test some of them. Fundamentally, as you know, the challenge that we face in terms of regulation and approval is that the pace for development of AI is much faster than what regulators have been used to. And in that context, what do you actually regulate and which bits of it do you approve and take into practice, and what happens after that? That is the interesting question. How do you adapt to the data shift changes? How do you tap to the different settings where things might be different? That is a challenge. In this program, one of the first bits that we're trying to overcome is the adaptation to local settings. Take the temporal element out of it, which itself has different challenges, but into local settings. The exciting thing is about this, as you just mentioned, several European countries, but also outside Europe, that we are implementing it. And the way we think about it is trying to just come with a common data model that has got some basic that could be transferred, and yet and test the algorithms whether they actually work at that level first.
So can you explain it a bit more detail? Is okay. So we have centers from Africa and from South America, but let's say we add an additional center after the development of this kind of model. Yeah. So how can we implement this in practice?
Yeah. So the idea here is that to overcome the challenge of data sharing, which is a big thing. I mean, the AI is hungry in data, and usually it will essentially interfere with regulations such as GDPR, where personalized data cannot be shared to the same extent. So the way we think that we might be able to address that is to essentially extract the aggregate information at different local settings and transfer those into an environment where algorithms could be applied and tested and taken feature. And in that scenario, if a new center comes in, if we have managed to essentially solve that problem internally across many centers that we have, then it should be in theory relatively easy that center, without having to impinge on the data privacy issues, they would create the same aggregate information, upload it to a place where that algorithm could be run and give the information back to them. So there's no actual participant or patient level data that is being shared, but those insights that are being shared exchangeably.
But at the many sense that are part of this consortium, they're well equipped. They're big IT departments, they're academic centers predominantly. So how do we make sure that we really can scale across, and also in small centers who don't have this kind of equipment?
Yeah. No, that is it. That's got, I think, both a technical challenge that we have, but also, as you've just said, a resource challenge that we need to overcome. And what we are trying to look at is how can you simplify the process once we have learned through experimentation that you essentially give the new center a recipe to just saying that would be a relatively semi-automated transformation of the raw data into something that could be AI ready. So that is the idea that we're trying to go to. There are other solutions potentially that we need to experiment, but it's probably fair to say that we don't know exactly which solution is going to work better and which solution is going to work, and that is why precisely we have got that program.
So we just discussed it, more the technical aspects, right? The data aspect, but there's also a human side of things, right? It's just, if you look at also in this conference, we have to educate the workforce as well, but also patients. So what's your view how we can convince people, right, regarding the value of AI? Because there's quite a lot of skepticism still.
Yeah.
And what do you think is the roadmap to get the adoption, right, from a clinical but also a patient perspective?
Yes, I mean that there are certain aspects. I mean, in my view, there are certain must-haves that we need to consider in that context, right? One of them is transparency. As a patient level, they should be informed where part of the decision-making or the whole decision-making is supported by AI. That transparency, I think, is important to gain the trust of the end user. And a level behind that, to get that trustworthiness, is to just be able to unpack what is essentially drives that decision-making, and essentially make the models to some extent explainable. We know that you can't go to the same simplification that is done conventionally with statistics and data, but you can get towards that direction, that you get that transparency for model explainability to be applied. And amidst all of it, of course, it is the political step to just make that all the way the communication channels clear, be absolutely clear about what stage you are and how the model performs as you go through it.
Yeah, it's all in the European Union. We have the AI Act that people can opt out of that. The AI algorithm decides your clinical reasoning. Let's put it that way. Is there not a risk as well that we get like difference between the different kind of people, maybe was also different backgrounds in the socioeconomic status, for example, that we're going to use this kind of algorithms.
Yeah, and you're pointing an excellent, making an excellent point. I mean, which could itself lead to bias, right?
Yeah.
One of the things that we are worried about is that if the AI models are fed with a particular type of data because of exclusion, might be due to regulation, might be due to other reasons, that we get the wrong prediction or biased predictions in that context. And that is why we need to address bias right from the beginning and make sure in particular what we see the underrepresented populations are learned sufficiently and that the model does not bias against them. One of the values of that model that we have with transfer learning is hopefully you get wide heterogeneity across different places. And if the risk distribution, I call it a risk distribution, captures a wide range of the fraction of the population, then it should be less prone to biases at single centers or single individual places where there might be a gap in the particular areas that the model would not be able to cover.
Yeah, because that's really it's really a key issue. How do we engage, but also how do we make sure that the data is representative, right,
yeah.
and generalizable?
Yeah.
And I think there's a big challenge as well. We've done research as well, and we clearly show that people who are opting out or didn't provide consent, right, they were from lower socioeconomic status, and we build models, and then you institutionalize.
Yeah.
This kind of biases within your models itself. And I think in AI for Heart Failure with AI Passport, we try to make it transparent and to see at least that we show, of course also during the day, there's a lot of people are afraid of the fairness. But the question is whether are we fair today in our healthcare practice. I think more importantly is, of course there will be bias, we have to make sure that we show them.
Yeah.
Right, that we show them where it's based upon and in which kind of population is indeed valid.
Yeah.
So regarding, again, the clinicians, how do we make sure that they adapt this kind of methods?
Yeah.
Is there a way you think, okay, how should we move forward, and also as a society?
Yeah, I mean, this is a big question. I mean, in my view, the first step is engaging and working with them. I mean, that is that is the philosophy behind AI4HF. That is a multi-stakeholder approach. All people who are going to be affected by it directly or indirectly needs to be part of the solution, and they need to own it. This is not AI against clinicians. This is not AI against society. This is all together. And if you perceive it from that direction and communicate that this is a support, decision support system ultimately, hopefully we will get more trust and more willingness for people to adopt, and we overcome the inertia that may exist, or in fact the resistance amidst all of that. But having a smaller, if you like, early adopters embedded in the program and gradually move towards that direction, hopefully it fails to just overcome the challenges that we commonly see. Certainly what we see in the media is a lot of hype and a lot of anxiety against AI, that people perceive this to be something that will essentially make certain jobs redundant, replaces certain positions. I don't think that I think this is far from the reality, perhaps apart from some exceptions. And I think we need to, if you engage with those stakeholders, that becomes clear as we move towards that. Of course, regulation has got a role to play in this as well.
So that's quite clear. So I think it's really important also in AI for heart failure that we engage with clinicians as we do now today, with patients, but also I think in the next year with regulatory agencies, with payers, because that's a thing that we didn't discuss today, but hopefully next time is with payers for regarding reimbursement, ethicists, and we have to take this journey together. But I hopefully of today as well that we convince people we have to be part of this journey and not sidelined as well. So thank Kazem for this great talk, and we're looking forward everyone, and just keep an eye on our website for progress, and we'll be back next year with progress reports. Thank you.
Thank you.